Yes. So, okay. Good morning, students. Today our topic is C7, Unit 15. That is 3 and 4 membered ring heterocyclic compounds. 3 and 4 membered ring heterocyclic compounds. We are discussing our 3 and 4 membered ring heterocyclic compounds. 6 compounds are there. We are discussing one by one. Okay. First one is oxirane. First one is oxirane. Oxirane. The structure of oxirane is, this is a structure. Another name is epoxide. Simply we are also called epoxide oxirane. So now we are going to synthesis of this oxirane. We are going to synthesis. Then double bond alkene reacting with oxygen in presence of silver catalyst. Upon heating, then the product is oxirane is the product. So oxirane is the 3-membered ring. In this 3-membered ring, 1 oxygen, 2 carbon atoms are there. So this is the method for synthesis of oxirane. And second method is when double bond carbon olefins when reacting with peracids, peracetic acid, perbenzoic acid, metachloroperbenzoic acid, whatever you take any acid, double bonds undergo epoxidation, then forms oxirane. Oxirane is the product. Okay. In this compound, if it is only simple olefins are there, we are taking peracids. If alpha beta unsaturated carbonyl compounds, whatever, if we are taking alpha beta unsaturated carbonyl compounds for the preparation of oxirane, the suitable reagent is hydrogen peroxide and base. The suitable reagent is hydrogen peroxide and base. The mechanism for synthesis of this alpha beta unsaturated carbonyl compound to epoxides that with hydrogen peroxide and base, the mechanism is when base hydrogen peroxide first reacting with base, sodium hydroxide, base subtract the hydrogen from peroxide, loss of water molecule, then forms negative charge on oxygen. This negative charge undergo Michael addition at beta position of alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound, and which is again coming to beta carbon anion. Page number is 374. Page number is 374. Okay. So don't ask page numbers. Already I am telling that this is unit 17, unit 15. Based on unit, you can go and open your notes book. Okay. So when it is undergo enolation, then forms your negative charge. This negative charge attack at oxygen, then elimination of OH minus, then forms epoxide is the product. Next, fourth example is when beta halohydranes, when in presence of base subtract the proton from here, then produce negative charge on oxygen. This negative charge involves in displace the halide ion. Then the product is epoxide is the product. Plus X minus is the product. Next one is from 1,2 diols. from 1, 2 diols. When this 1, 2 diols first reacting with tosyl chloride, paratoluene, benzene sulfonyl chloride. So in presence of base by loss of HCl, H is replaced by tosyl, one hydroxy group, that is tosylate. This is called tosylate. This tosylate involves is easy leaving group tosylate. Then loss of paratoluene benzene sulfonic acid, paratoluene benzene sulfonic acid. Then the product is oxygen is the product. And from fourth one is from carbonyl compounds. From carbonyl compounds. From carbonyl compounds. When the carbonyl compounds reacting with diazomethane, carbonyl compounds when reacting with diazomethane. So diazomethane undergo loss of nitrogen gas, then produce oxygen is the product. Oxygen is the product. So mechanism for the synthesis of this carbonyl compound diazomethane to oxygen is here. The structure of diazomethane is CH2 minus N triple bond plus. Okay. Now it is first it is involves negative charge attacking on carbonyl carbon, then produce CH2N triple bond positive charge O minus. This minus attacking at the carbon and elimination of N2 gas, then produce oxygen is the product. Simple, oxygen is the product. So next one is reactions. These are synthesis of oxygens. Next one is reactions of oxygens. Reactions of oxygens. Reactions of oxygen. Oxidants ring is attacked by electrophile, nucleophile, and dehydrogenating agents, leading the opening the. So when the oxygen ring is unstable, when attacking of electrophile, oxidizing agents, the open ring will be open takes place. Okay. First one, reaction with acid medium. Acid medium, reaction with acid medium. When it is in oxygen having lone pair of electron, this lone pair of electron donate to H plus, then forms positive charge on oxygen. Now when it is reacting with another mole of water molecule, attacking it here, then ring is open takes place, then forms glycol is the product. 1, 2 dialcohols, glycols are the product. This is a symmetrical oxygen, no problem. If we are taking unsymmetrical oxygen, what is the mechanism I explain here? When the epox, same acid medium, open attacking here, then positive charge on oxygen. Okay, now it is reacting with water molecule. There is a two possibilities is there. If attacking it here and attacking it here, that means that in case of unsymmetrical epoxides, oxidants, the opening of oxidant ring is in acid condition, opening from more substitution side, because the stability of carbocation. They explain the stability of carbocation. That's the condition. Next one is reaction with organometallics. Reaction with organometallics. Reaction with organometallics. When oxygen reacting with methyl magnesium halide, the negative charge on methyl group is opening the ring in presence of water molecule. Methyl is the product. Next one is photochemical rearrangement. Photochemical rearrangement when oxygen undergo influence of sunlight, shorter wavelength, and in case of longer wavelength, the product, in case of shorter wavelength, the product is CH2, methane is the product, and oxygen. In case of longer wavelength, the product is aldehyde. The product is aldehyde. When we reacting with deoxygenation, deoxygenation, in case of deoxygenation, oxygen reacting with triphenylphosphine, the ring is open, then forms triphenylphosphine double bond O. Oxygen is the product. This is the mechanism for this reaction is, so here triphenylphosphine is Lewis acid. Therefore, they abstract the lone pair of electrons from oxygen. Triphenylphosphine positive charge. Therefore, the bond is that this carbon oxygen single bond is shifting to phosphorus oxygen side. Therefore, this another carbon oxygen bond is shifting towards the carbon. Therefore, double bond and triphenylphosphine is the product. This is the oxygen. Next one is thyrenes. Thyrenes means three-membered ring with one sulfur atom. Three-membered ring with one sulfur atom is thyrenes. Next one is synthesis of this thyrenes is synthesis. We are going to synthesis, discussion with the synthesis. That is 2-mercaptoethanol. This is 2-mercaptoethanol. This 2-mercaptoethanol, when reacting with SOCl2 phosgene reacting with SOCl2 by loss of 2 moles of HCl, they forms a five-membered ring with oxygen and sulfur. It is involves opening the ring, undergo thyrene and carbon dioxide is the product. Next one is 1,2 diols. Next one is from 1,2 diols. Same. From these 1,2 diols reacting with SOCl2 by loss of 2 moles of HCl. By loss of 2 moles of HCl, when it is reacting with SCN, cyanide and S minus attacking one of the oxygen carbon bond, and this bond is shifting towards oxygen side, then SCN O double bond O minus. It is involved in elimination of carbon dioxide gas. And O minus. This O minus attacking it carbon of cyano, and this pi bond is shifting towards nitrogen side. N minus. This N minus I'm going to reverse attacking, then forms thyrenes plus N double triple bond O minus is the product. This is the method. And fourth method is from oxiranes. Fourth method is from oxiranes. Third method is oxiranes. From oxiranes. From oxiranes. M.Sc.N. When this is obtained from epoxides, when reacting with HSCN, when attacking at opening of the ring, when it is reacting with the base, then forms styrene is the product. Styrene is the product. So, okay, the mechanism here. The mechanism is this is one method. And next one is this is a synthesis of styrene from oxiranes. Next one is reactions. Styrene are relatively less stable than oxygen. Styrene is less stable than oxygen. So styrenes are cleaved by electrophilic and nucleophilic reagent. By attacking of electrophilic and nucleophilic reagent, styrene ring will be cleaved. So reaction with electrophilic reagent. Reaction with electrophilic reagent. Reaction with electrophilic reagent or S. When reacting with HCl, H plus Cl minus attacking it here, opening the ring from more substitution side, here Cn and Hs, the mechanism. So wherever we take in any electrophiles. Next one is reaction with nucleophile. Next one is reaction with nucleophiles. So when thyrenes reacting with water molecule, opening from less substitution side. So if it is reacting with amine, primary amine, so this is a mechanism. Next one is desulfonation. Desulfonation when tyrene reacting with PO triethyl compound or N-butyl lithium, the sulfur atom is eliminated, then produces alkene is the product. The sulfur atom is eliminated, alkene is the product. Next one is oxidation. Oxidation when tyrene reacting with NaIO4. So oxidation takes place on sulfur. Then it is reacting with 100 degrees Celsius heating and then forms alkene plus sulfur monoxide is the product. Next one, aziridines. Third one is aziridines. The third one is aziridines. aziridines. The structure of aziridine is NH. Three-membered ring. Aziridine is a three-membered ring with one nitrogen atom. One nitrogen atom. Synthesis of aziridine is from Grabial ring synthesis. Grabial ring synthesis. In this synthesis, alpha haloamines. Alpha haloamines. Alpha haloamines in presence of base. In presence of base. So elimination of HX, NH, double bond like this. This is the mechanism. Next method is Hassner's method. Hassner synthesis and Hassner method. In this method, when alkene reacting with INCO, that iodine, NCO here. When this compound reacting with methanol, this compound is reacting with methanol. So methanol attacking it nitrogen, double bond, nitrogen. Then iodine, N-methyl, valbanvo-O-methoxy. So when this compound reacting with base, so elimination of this total moiety then forms aziridine is the product. Aziridine is the product. Next one is from alkenes and azides. From alkenes and azides. From alkenes and azides. When alkene reacting with alkyl azide, undergo triazoles or formation takes place. Triazoles or formation takes place. In this triazole, the bonds are shifting takes place like this. Elimination of N2, they forms aziridine is the product. Aziridine is the product. From oxirines, when oxirane reacting with iminophosphorines, iminophosphorine at 140 degrees, then forms aziridine is the product. Aziridine is the product. Fifth one is Hatch-Kammler method. Hatch-Kammler method. Oximes of carbonyl compound having alpha hydrogens. Oximes of carbonyl compounds having alpha hydrogens. Oximes of carbonyl compounds having alpha hydrogen, at least one alpha hydrogens, reacting with Grignard reagents. Grignard reagent act as a base. Base abstract the proton from oximes alpha hydrogen. Oximes alpha hydrogens, negative charge. This negative charge attack it oximes nitrogen. Elimination of OH minus, then forms aziridine. This aziridine undergo reduction with lithium aluminum hydride, double bond undergo reduction, then forms aziridine is the product. Next, reactions. Next, reactions. 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 So first, as a NH at NH function, reaction at NH function, at NH function. So as written with the free nitrogen function, reaction with a variety of reagents. Variety of reagents. Just I'm given two, three, four examples. Where it is reacting with NaOCl. So NaOCl, then chlorination. When it is reacting with the acrylonitrile in presence of base, Michael addition reaction like this. Okay, any lot of examples are there in functionate nitrogen. Ring opening. Ring opening. Ring opening of aziridines takes place by reaction with electrophilic and nucleophiles. Okay. Reacting with the electrophile and nucleophiles, rings are opening takes place when reacting with HCl. When reacting with HCl, so H plus Cl minus attack it here, then forms NH2Cl. When reacting with amines, same here NH2 and NH are so like this. When it is reacting with water molecule, so water molecule attacking it here, NH2OH, hydroxyl alpha amino ethanol is a product. Like this reactions are there. Next, fragmentation reactions. Next one is fragmentation reactions. Fragmentation reaction. In this fragmentation, first one is electrophilic ring opening. Ring opening, electrophilic ring opening. First one is electrophilic ring opening. In this electrophilic ring opening, aryl methyl ester. This is ester. Here hydrogen. Fragmentation takes place at 100 degrees Celsius. The bonds are undergo rearrangement. One pair of nitrogen attacking and elimination, then forms N positive aryl ester, hydrogen ester, here negative charge. When it is reacting with any double bond, I am taken XY, any double bond. So undergo 1, 3 dipolar addition reaction. 1, 3 dipolar addition reaction like this takes place. XY, N aryl, C ester, acetate. This is the product we are getting. Okay. Next, fragmentation reactions. Fragmentation reaction. In this fragmentation reaction, triphenyl aziridine in presence of sunlight in ethanol. In presence of sunlight ethanol. In presence of sunlight ethanol. The bonds are undergo rearrangement. Phenyl, hydrogen, N-phenyl plus phenyl CH2OR is the product. Okay. The mechanism for this here, same previous case, the lone pair of electrons are nitrogen donated towards ring and phenyl plus phenyl hydrogen negative. So now it is undergo fragmentation, then forms this is the product and this is the mechanism. Next one is rearrangement. Rearrangement. N-acyl aziridine undergo rearrangement. Then convert into 5-membered ring. 3-membered ring is converted to 5-membered ring. Next one is oxetane. 4-membered rings, oxetane. Next one is oxetane. The structure of oxetane is 4-membered ring with 1 oxygen atom. Next, we are going to synthesis of this oxetane. Synthesis of oxetane. First method is Paterno-Bucci reaction. Very, very important. Paterno-Bucci reaction. Paterno-Bucci reaction. When double bond reacting with carbonyl compounds, double bond reacting with carbonyl compounds in presence of sunlight, then undergo 2pi plus 2pi cycloaddition reaction, then forms oxetane is the product. So this is one method. And second method is from oxidanes. These oxidanes reacting with the DMSO, dimethyl sulfonide chloride, and negative charge here, positive charge. Now here attacking it, this negative charge attacking it, epoxide carbon, oxidane carbon ring will be opened, then forms methyl taken to double bond O positive and negative charge. This need to attack it here and elimination of sulfur DMSO, then forms our oxetane is the product. Next one is reactions. Oxydanes are strong. Oxytane is a strong Lewis base. Then oxidanes ring straight is less than that of oxytane. Okay. Opening of the ring. Categorical opening of the ring is when reacting with HCl. Ring open takes place like this. When it is reacting with ethanol, This is the products of the formation takes place. Next one is base catalyzed ring opening. Base catalyzed ring opening. Base catalyzed ring opening. So this is example, and this is the amines. Next one is benzyl thioalcohol. Ring opening takes place. This is the product. Okay. Next one is thermal rearrangement. Thermal rearrangement. Thermal rearrangement. When this compound 300 at 300 degrees Celsius heating, so last undergo convert into olefins and oxy, convert into carbonyl compounds. Next one is rearrangement reaction, photochemical reaction. Photochemical reaction. In presence of sunlight and photosensitizers, they convert into four-membered cyclobutanone, oxetane converted into cyclobutanone. Phenyl, here phenyls, then convert to methyl. So now here rearrangement undergo in presence of sunlight, undergo homolytical cleavage, and two radicals are formation takes place. And these radicals are unstable, undergo bond cleavage like this takes place, then forms shifting of bonds again. Yeah, that bonds formation between these two radicals and bond will be formation takes place. Next one, thioethanes. Thioethanes means four-membered ring with one sulfur atom is thioethanes. So next synthesis of this thioethane is from 1,3-dihaloalkenes. 1,3-dihaloalkenes. And 1,3-dihaloalkene. When this 1,3-dihaloalkene reacting with Na2S, loss of NaX, 2 moles of NaX, then forms thioethane is the product. Next one is first method. Second one is 1,3-dihalo compound. Diols come from 1,3-diols. When 1,3-diols reacting with H2S, elimination of 2 moles of water molecule. Elimination of 2 moles of water molecule, then forms thioethane is the product. Reactions. Next one is reactions. Ring opening reactions. When it is reacting with HCl, ring open takes place. SH and HCl reacting with amines. So like this ring opening takes place. Next, when it desulfonylation. Desulfonylation. This titane derivative, when this titane derivative reacting with Raney nickel, then elimination of sulfur and a three-membered ring formation takes place here. So three-membered ring formation takes place. Next one is azitidines. Azitidines. So a four-membered ring with one nitrogen atom is azitidine. Synthesis of this azitidine is from 3 bromo propylamine, 3 bromo propylamine, 3 bromo propylamine in presence of base. So elimination of HBr then forms azitidine is the product. Okay. Next one is from azitidines. From azitidines. From azitidines. Then azitidines under reacting with double bond carbon then forms azitidine is the product. Here synthesis of mechanism here. Bond breakage takes place, then forms again positive phenyl methyl negative charge. Then this compound reacting with double bond undergo 1,3 dipolarization reaction. 1,3 dipolarization reaction. Then the product is azitidine. Azitidine. Next one is next one is from isoxazoles. From isoxazoles. From isoxazoles, when isoxazole reacting with tosyl chloride, when it is reacting with sodium ethoxide, elimination of paratoluene sulfonic acid, then the product is TS and methyl. So this is the product synthesis of azitidine derivative. Next reactions. So azitidine is undergo electrophilic and nucleophilic addition reactions, electrophilic and nucleophilic addition reactions. When it is reacting with carbon disulfide, then it is forms double bond S minus. It is reacting with HNO2. Nitrosylation takes place on nitro. These are examples. This is the reactions. This is a synthesis of azitidine. Okay. Next class we are continue into next Friday. Thank you. and definitely I will provide a notes within 1 or 2 days. Thank you.